Okay, so welcome everyone once again. We're about to start. We waited a few minutes for more attendees to join, but in any case, the webinar is going to be recorded, and other attendees may be able to join as the recording is unfolding. But I think it's time to start. So thank you for the interest expressed in the academic challenges. I'm Francesco Liucci from ESA and responsible for the BSGN initiative, and I'll introduce the webinar, and I will be the first to start with my presentation, and I'll be able also to show you the agenda and how the rest of the webinar will proceed. I assume you can all see the screen. Yes. So this is the webinar for the academic challenges linked to the Space for Inspiration Commercialization Conference that we'll have in September. The agenda for today will be divided across the BSGN accelerators and myself, who I'm responsible for the BSGN initiative. I'll start with a 10-minute presentation to give an overview of the conference, the scope of the academic challenge, and some information related to the scope of the call and details related to it. And then we will have each of the accelerator to present its own track and introduce itself, the work done to date, and give some guidance related to the scope and the specific targeted market that we would like to address with this call. We finish with a generous portion of time dedicated for Q&A, so the attendees are invited to ask any question, and we'll make our best to answer during the webinar or afterwards. So, Space for Inspiration is an important commercialization conference related to the market that are of focus for the Business in Space Growth Network initiative in microgravity and related to lunar exploration. It's going to be held in Copenhagen, thanks to the partnership with the Ministry of Higher Education and Science in Denmark on the 1st and 2nd of September. And the overall theme of this conference is really scale up and how to scale up the effort in commercializing these markets and to grow the commercial ecosystem that exists today in this environment. In the scope of this conference, we have launched the academic challenges, which are really aimed to address the academic environment and uncover new concept ideas that start from the research and the academic environment, but they could have commercial potential. At this link on the title, you will be able to access the call on the OSIP platform. A reminder on top of the slide that the deadline for submission is on the 5th of June. And the three main tracks will be described in a moment. We're seeking innovative scientific concepts with potential for future commercialization related to track number 1, health and life sciences related to microgravity. Track number 2, advanced material and space manufacturing. And track number 3, space resources with the focus on construction applications. The objective of this call is really to identify new concepts that comes from research, but they have future commercialization potential in the key market where the BSGN today operates. We would like with this to build a bridge between academia and potential future industry stakeholders in these markets, stimulate the emergence of new commercial pathways and provide the selected academic teams with the technical and commercial coaching that would help them to mature their idea and guide them towards the next steps. Very briefly, the criteria that we will adopt to evaluate the application, that will be largely weighted around the innovation potential of the application we will receive. And then there will be an equal weight applied for technical feasibility and commercial potential. We are really targeting early stage ideas, so the key criteria is really the degree of innovativeness that this idea can provide in the specific track. In terms of prizes, we will select 3 finalists for each track, and those will receive free ticket and accommodation for the Space for Inspiration conference. The travel will need to be paid by them. And those 3 finalists will be supported by the BSGN accelerators. They will have some light support in terms of pitch preparation, because at the conference, they will compete they will present their idea. There will be a pitch competition, and we will announce 1 winner per track. Each of these winners will be supported by the BSGN accelerators, providing in-kind acceleration support in order to mature their ideas, their use cases, both on the technical and the commercial side. And the end goal is to provide a final report with the maturation that has occurred for each of the 3 winners and guidance for the next steps, which could be the support provided by other ESA commercialization tools or other means related to partnership, licensing of IP, or whatever else we understand together with the winners that is the best way to proceed to let this idea come to fruition. And I think it's important to give an overview of the entire BSGN initiative. Today, the Business in Space Growth Network is composed of mainly 4 industry accelerators. Each one is dedicated on a different market segment: agri-food, health and life sciences, advanced material and space manufacturing are focused on the use of microgravity environment as unique place where the specific characteristic of microgravity could be harnessed to give a unique selling point, to give a special environment where certain specific demonstration or experiment can be executed, and to turn these results into commercial solution that could be used on terrestrial markets. The 4th one is on lunar space resources. It's a little different because it's focused on lunar exploration, and his core effort is related to the development of the overall space resources value chain. Each of these accelerators is managed by an external organization, which is partnering with ESA, and is managing the day-to-day operation of the accelerator, supporting the project selected, and executed the end-to-end activities assigned to each accelerator. In a nutshell, the model of the industry accelerator is pretty simple. ESA provides an incentive which pulls together up to 50% of the funding that can go towards the implementation plan, so the plan for a testing or a demonstration that is executed in a suitable environment according to the specific accelerator under which the project is selected. So for microgravity, the goal is really to have an in-orbit demonstration. And for space resources at this stage, the focus is to have a demonstration in terrestrial environment. And moving forward, the goal will be increasingly more towards a lunar demonstration. This incentive is funding together with the acceleration services, so the support on both the technical and the commercial side provided the managing partner allocated for each accelerator. For the 3 microgravity focused accelerator. The support is more directly related to incentivizing and supporting the commercial demand that is emerging in this market. So terrestrial companies, they're interested in using microgravity for R&D projects that can have a commercial end goal. And for lunar space resources, it's more holistically related to the development of the space resources value chain, which in turn underpin the future creation of a lunar economy. To give just some key numbers, since its inception, BSGN now counts 4 accelerators for the 4 targeted markets that I've just presented. We have 20 projects that have been either supported in previous cohort or currently under support in the current activities. 6 projects have executed in-orbit demonstrations. 3 projects are set to fly between 2026 and 2027. And 9 more projects from the current cohort are expected to do a testing or demonstration between 2027 and 2028. To date, not counting the private investment that we expect to receive to match ESA contribution in the current cohort, we've unlocked almost 4 million of private investment that came from the project supported to match the ESA contribution. A little bit of recent history. The project that you see on the screen are the 3 cohorts that we had in the first phase of the accelerators. We had 5 projects supported by the accelerator managed by MEDES in health and life science. We had 2 projects supported by advanced material and space manufacturing, led by the satellite applications Catapult, and 2 projects in the agri-food accelerator. You can see in green the project that have already executed or they are doing an in-orbit demonstration or a testing. Very recently, Photocentric, the project number 6, has executed successfully parabolic flight as a precursor to the microgravity testing. And the project with Roche and Space Pharma has announced that they will soon have an ISS experiment. And more projects are finalizing their steps towards the same goal. These that you see on the screen instead are the 11 projects that they are currently supported in the new cohorts for each of the accelerators. And we have the agri-food accelerator, which is ramping up the activities and is expected to launch a new goal for project between the end of this year and the beginning of next. So these are the general themes and information related to the call and its scope. I give the floor now one by one to each track and to each accelerator, which can present itself and provide more details about each of the targeted market and the ideas that they would like to receive for the call. Thank you. Just a quick reminder that we won't stop between the presentation, but we will have time after all of them for Q&A. So if you have questions, you can take note or write already in the chat, and we will answer afterwards. So I leave the floor now to MEDES, our partner that is managing the accelerator for health and life sciences.
Hi everyone, I hope you are able to see my slides. Let's start. Thank you for letting me speak today. I'm here to discuss the health and life science track. So just to start, a word about MEDES. So MEDES is a private company, but more importantly, this is a joint venture between the French Space Agency, the CNES, and the French hospitals. And most of the staff is based in Toulouse, in France. So most of the team is composed of biomedical engineers, of space system engineers, and people from IT. I think the most famous part of MEDES is the space clinic, where we reproduce the effect of microgravity on the human body. We also have teams that operate life science and physiological experiment on board the ISS. And my colleagues and myself are working with the BSGN activity. We are in the innovation and application department. Presentation about the life science industry accelerator. Here it's to, as the same as all the accelerator, we are here to stimulate the commercial space ecosystem in low Earth orbits, and to reach people that are not used to work with microgravity in their R&D process in the field of pharma, biotechnology, bioproduction, or cosmetics. We'll let them aware about the asset of microgravity. We work usually with market-driven activities. We aim to sell terrestrial challenge, but if there are application for deep space exploration too, we're interested. And most importantly, we want to push back the boundaries of what is standards of R&D process in private companies. So why microgravity is an asset for life sciences? Just to let you know that different behavior of living organisms. There are changes in the gene expression, there are morphological modification, and changes in the cellular physiology. Something very important, the protein crystallization, where molecule crystal grow bigger and with fewer defects. There are new morphologies, and the organelles tissue are also in the same trends, where it's easier to grow complex 3D tissues without to have the gravity applied on the tissue. So they grow in a different manner. And for the maybe more for product in the industry, in bottles, for instance, the separations of phase is not happening in space. So the study of the lifetime life of the product is not impacted by this effect. And also the accelerated model of the aging model is also different in space. It's accelerated, and it's important for disorders such as osteoporosis. So what expect from the accelerator? So our objective is to mature very raw ideas or ground-based health research to a space-enabled innovation on the pathway for space. What you will benefit is a one-to-one relationship with MEDES, and also a set of workshops to transform the idea up to a concept ready for space implementation. So with the technical aspects, and also for the commercial perspective. So this, just a reminder about the timeline. So here in the moment, in May 2026, we are collecting ideas. Then we're gonna have a process to evaluate those ideas. Then 3 projects will be shortlisted. We're gonna provide some pitching training to make them ready for the Space for Inspiration event. And then 1 finalist will be selected for the project maturation. This is a short acceleration to make sure that you are ready for the space sector, contact with the right suppliers, and also the right funding process. Just an overview, as Francesco already presented, cohort example of projects that have been selected for the 2 cohorts. There are some projects like with a strong involvement from academia and also for the industry. We have a ZEPRIUN and others that we will discuss later on. And we also have a lot of projects related to 3D bioprint tissue for Roche and crystalline commercialization, human organoids. Priscilla and MERS Perscardio are currently under acceleration. The first one is focused on primary cilia and the mechanosensing with the use case of cartilage, and MERS Perscardio is focused on cardiac tissues. And just discuss the use case of ZEPRIUN is with a strong involvement of the academia from Italy and from Spain. This was about the growth of protein crystals. They were launched in August 2025. And what's very interesting is that they got a very higher quality of protein crystallization. And why is it important? Because it allows them to have drug optimization and to have new pipeline for drug development, and with strong applications with prion disease and neurodegenerative disease. The next use case is horse. So this one has also a strong involvement of academia, and this is a French consortium. They aim to develop a space-dedicated lab using nanoporous tumoroids technology to study glioblastoma multiforme in microgravity. So they have been launched very recently in April 2026. We hope they're gonna retrieve their sample in this summer. For them, space is a unique environment for tumor biology and immune response. So it's exposed their tumoroids to space conditions that reveal drug sensitiveness, and they allow them to identify potential immunological effects. And why is it important? This is for the personalized medicine drug proposition for current glioblastoma multiforme case, to develop tumoroids avatar. And this is also applicable for neurodegenerative disease. And the market, the aim is the brain tumor treatment. So thank you, everyone. Here there is a contact to reach the team if you have any question. I will share it in the discussion, and please follow MEDES on LinkedIn so you won't miss any information. And there is also a link to apply for the call. So thank you very much, everyone.
Thank you very much, Angélique. So this was MEDES for the track number 1 on health and life sciences, and thanks for providing some overview of the work you've done and some of the use cases coming from the project you supported. Now it's time for track 2, advanced material in space manufacturing, led by the satellite applications Catapult.
Perfect, thank you.
Oh, thank you very much. Yeah, thank you for that. Yeah, so we're the Satellite Applications Catapult, and we're running the Advanced Materials in in-orbit manufacturing, the Academic Challenge Accelerator. What I would like to say is it's not just myself presenting here, it's going to be a nice little duet between myself and Joel. So I'm going to run through the technical aspects to begin with, and then Joel will run through the details of past successes, hopefully future successes, and how we will run this accelerator. Next slide, please. So we are based in the UK. We are running the Materials Accelerator, but we are predominantly the UK based, but we try and reach as far as we can across Europe, and in fact across the globe. We run across 3 sectors within our organisation. That is Sustainable Earth, the Connected on Autonomous Earth, and our team is within the Beyond Earth. So what do we do outside of Earth's atmosphere? And this is the area where we're trying to look at. we've got a breadth and depth of facilities and expertise in this. And not only is it in-house facilities and expertise, again, who we are and the nature of us as an organisation, we can reach out to organisations and industry across the UK, as we're a trusted neutral entity. And as you can see, we might be a small nation on the right hand side, or a cluster of nations. There's quite a lot of activity within the space ecosystem here. So even if it's not ourselves that can assist with you, what we can do is we can put you in contact with the right people should we be of any use. So next slide, please, John. So again, this accelerator is within the BSGN, and I've been informed that my camera is not on, although I can see my lovely face on my screen. So I think this is an issue. So I think they're going to have to just look at you, Joel, at the moment, I'm afraid. So yeah, we run the advanced materials manufacturing track, and what we're trying to do is bring organisations into this sector. One of the key points we want to drive here, and I think is not just within the materials aspect, it's across all of these sectors, all of these tracks, is it's not just space organisations that we want to get in here. This is traditionally terrestrial organisations that can use space and the benefits that come from it to help enable other product lines for them and maybe even improve their current products. So this accelerator is trying to bring people in from non-space. We're not saying that people that are traditionally in space aren't welcome, but we're trying to reach out quite wide here and reduce that barrier to entry so we can actually improve the manufacturing capability and try and get a commercial output from this, because this is what we're all trying to do here. It's the business in space, not the technology in space. So this is what we're trying to do. And the point of the academic accelerator here is to drop down a TRL level rather than looking at this purely commercial. How do we seed some commercial activity with the ideas that you and the audience have today, and or people that you know in your network? How do we bring these forward and actually get them thinking, this smart idea that I'm currently working on, I can use this as a commercial activity to benefit humankind, if I want to be as broad as this. If we can move on to the next slide, please, John. So whilst we are talking about our individual sector here, our individual track, we're trying to broaden or narrow this down to 3 themes. So we've got the in-orbit materials discovery and optimization, in-orbit materials processing and manufacturing methods, in-orbit fabrication of materials and components. This is to try and aid with your applications here, and our evaluation of it is to try and get you through and go, okay, this is where I fit. This is where my idea aligns. What we've got here, so take theme 1, it's really about understanding how materials are going to behave differently in space. How do you use the microgravity? Is convection an issue? Is sedimentation an issue terrestrially? Okay, let's take this in, and this is the theme where you can apply. The second theme is focusing more about the manufacturing process itself. So rather than the final product, what we're asking is how do we actually manufacture something in space? That could be additive manufacturing, it could be joining, deposition, feedstock handling. Essentially the tools, methods, and process control needed to build the reliable manufacturing capability beyond Earth. Typically, we think of a factory terrestrially. We can go in, we can manually inspect something, we can maintain it quite easily. These are all factors not in space. You can't send someone up quite easily to do these. So do you have a novel method that can allow you to make something in space without almost maintenance free? And then the third theme is the actual output. This is about producing usable materials, functional components in orbit. You see one of the big examples, you've got Z-bland fibers being manufactured on the ISS. There's a fantastic image of the astronauts aboard the ISS, and essentially it's a 5-kilometer spool of fiber optic cable. So these are the kind of things what we're trying to look at in the third theme. But one thing to remember is these themes are intended to just guide your thinking rather than completely limit it. We're really interested in concepts that bring new industries and new ways of thinking in the space manufacturing ecosystem. So this is how do we start to scale up? How do we start to commercialize these manufacturing opportunities in space? Whilst my camera's not on, I will be able to answer any questions. Well, I say answer any. Hopefully, I'll be able to answer any of your questions that you may have in the chat. And thank you for listening to me drone on. I'm now going to hand over to my handsome colleague, Joel.
Thanks, Alex. So I'm Joel Freedman. I'm Head of Innovation Services at the Satellite Applications Catapult. I won't go into too much detail about the process, as you heard a bit of it before from Medes, but just to reiterate the key dates, the call closes on the 5th of June. 2 finalists will then be chosen to pitch at the Space for Inspiration event in September. And between being chosen and pitching, you'll get 2 pitch support sessions from our team. And then the winning team will have their full support shortly after Space for Inspiration from September to December. Similarly, again, to what you have already heard, the support you'll be getting will be a combination of understanding the commercialization landscape, the pathways to go from research into an actual service, and where the various components are that can get you into space, that can do things in space, and where relevant, bring you back. How to shape your value proposition as well, to understand your potential users and customers, and also know what evidence they would want to see when you're creating experiments that will prove your value proposition. We'll be supporting around the kind of commercialization approach. How do you get funding, starting a business, spinning out, generating and protecting IP, and how you can move from that idea to either a business or IP that gets licensed out, and funding and acceleration pathways. So a lot of this is around getting you ready for that next step, in-orbit demonstration and commercialization. So the things we can do that mean after you've had the support, you're able to make the most of the other funding programs that are out there and kind of follow-on support. So I'd like to give you some examples of businesses that have been and are currently on the program on advanced manufacturing materials. So on our first cohort, we had 2 really strong examples of what the accelerator is here to do. So taking promising technical concepts and moving them towards credible in-orbit demonstration and commercial readiness. So the first was Photocentric, developing Cosmic Maker, an autonomous multi-material 3D printer designed for manufacturing in space. The ambition being to produce high-performance parts, including silicon carbide components with properties such as enhanced strength, thermal performance, electromagnetic shielding, and electrical functionality. And through the accelerator, they were able to design, prototype, and refine that system. And the latest update is that Cosmic Maker has now moved into zero gravity validation. As part of UK Space Agency supported work, the team has taken the printer onto an ESA Novaspace parabolic flight and demonstrated printing through both 0G and 2G phases. So a really tangible step from concept to prototype and then relevant environmental testing towards in-orbit. The second company was D-Cubed, so working on next generation high-powered solar arrays. So their proposition was about getting more power from compact, scalable arrays, which are critical for satellites with tight volume constraints and growing power demands, as well as a whole range of future in-space structures. Since the accelerator, D-Cubed has spun out its solar array activities as Aricus. Their first demonstrator launched in January of this year to demonstrate in-space manufacturing of a boom. And the second Aricus D2 mission is focused on printing and deploying a 1 meter in-space manufactured solar array. So for future cohorts, which hopefully will be people who are on this call, the thing to take away is this isn't just leading towards business support in the abstract. This is an accelerator helping companies to take those ideas and create technical plans and commercial routes to getting from the lab and into space. From the first cohort, we now have 3 companies on our second cohort, showing quite a range of different opportunities. So the first is Flawless Photonics, focused on microgravity production of Zeblan sort of fiber optic fiber, optical fibers. And so they've already demonstrated progress on the International Space Station, and they've produced a number of kilometers of fiber. The accelerator is now supporting them as they move towards a more automated and scalable in-orbit production. So the opportunity is by moving gravity-driven defects, you open up higher performance optical materials for communication, sensing, imaging, and all of the next generation photonics. And as the applications terrestrially move really fast, the requirement for high performance fibers increases. Arc Space addressing a very different but equally important capability gap, and this is on-orbit joining and cutting using electron beam technology. In fact, they're looking at a whole suite of tools for cutting, joining, producing, constructing in space. And if we want future in-orbit servicing, assembly, repair, and creation of large in-space infrastructure, we need these tools to process and join and cut materials in space. So their project is about validating the welding process and contamination management in microgravity as a step towards commercial in-orbit servicing and assembly applications. And finally, Levion Materials. So they're looking at space-enabled production of advanced semiconductor materials. So the underlying idea is that in microgravity, effects like gravity-driven or buoyancy-driven convection, sedimentation, and segregation are reduced, which allows this higher purity, lower defect crystal growth. And like fiber optics, that has huge implications terrestrially for applications in electronics, sensing, and quantum technologies. So across both cohorts, you see a real range of things that are sort of for space and for Earth as well. But the message is, if you have a material process manufacturing capability where the space environment genuinely changes what's possible, this track can help you, and this accelerator as a whole can help you turn that from a promising idea into a credible mission. So hopefully you noticed there is a QR code that has been across all of the slides. It's here now. There will be lots of links to apply as we go through this webinar. But if you would like to find out more, please don't hesitate to get in touch. And we hope as many of you as possible submit your ideas. So thank you very much.
Thank you, Alex. Thank you, Joel, for presenting what Catapult has done with the BSGN Accelerator to date, and also very good to be able to see and hear the latest from two of the projects that have been supported. Now it's time for the BSGN Industry Accelerator focused on space resources. We have ESRIC, which is the Center of Excellence for Space Resources in Luxembourg, which is managing the accelerator on behalf of ESA. And I leave the floor to Kenneth for the presentation together with Ernestina.
Hello, everyone. Good morning. I think that I'm sharing, right? I am.
Yep, we can see it now.
Okay.
Thank you.
Good morning. So I'm Ernestina from ESRIC, and I'm working as a project manager in different activity, and as well supporting the accelerator. And I will give the word to Kenneth. Kenneth, maybe you want to introduce yourself as well?
Yeah, hello, my name is Kenneth Liang. I am the Space Resources Accelerator Officer, so I will be helping you all in your applications.
Good. So I'm starting the presentation, the generic one, and then when we are going deep in the academic challenge, I will pass the stage to Kenneth. Okay, so the first one is the introduction of ESRIC. Not sure if all of you know us. So we would like to be the Center of Excellence in Space Resources Activity. And for that, we are considering what we call the three main pillars. So the research, the commercialization, and the community. The three pillars are related to our stakeholders that are the Luxembourg Space Agency, the Luxembourg Institute for Science and Technology, where we are, let's say, part of it, and then the ESA, as we are in partnership with ESA in different activity. So we do research, and I will explain to you later on which kind of research we do in space resources activity. And then we have different commercialization activity and the community that would like to bridge together all the stakeholders in space resources. We don't have, we are not deep diving the community activity, but mainly we have an ESA ESRIC challenge and the Space Resource Week that ended last week. So related to research activity, well, we are in the space resources research field. That is quite a broad field. We cannot do everything, but we do quite a lot of activity. So the first one is the extraction of oxygen and water from the regolith, and then the purification as well for different usage. We do as well a lot of activity in terms of beneficiation, size classification, and as well in regolith handling. We started some analysis in construction, mainly with the microwave sintering and melting. We are having a lot of design activity related to recycling, because everything that is left in space on the moon can be considered as debris, and so recycling activity, and also a lot of simulation and analysis of the dust. We have as well the prototypes area that is in developing, and we do some analysis in system evaluation and optimization for the process. Obviously, as I said, the oxygen and the metals extracted from the regolith are one of the main activity of research. On that we have as well a few PhD and postdoc that are working. You can check in the website of ESRIC all the activity that we have. I would like to focus mainly on our commercialization part, as we have a startup support program that is the unique one on space resources. I put here some picture that we gathered in 2025 and 26. Space Resource Week related to the cohort that were selected. And then just to underline that we supported so far 6 companies, and then you can see here the different field of activity that they added, and they are all around Europe and beyond. So we have the first one was the project RI with autonomous transport platform. The company was 4 Point. Then LightEgo Space with a resource characterization, so a LIBS instrument, space backend in connectivity, Radiant with oxygen extraction from regolith, Tumi Robotic with autonomous exploration, and then Polymac with regolith handling. So it's to give an idea which kind of company we can have in space resources activity. Then to deep dive in the accelerator, what we do? We started with the first cohort in 2025, and then the project will finish in 2027, and we have we start in 24 the discussion with ESA. At the beginning, the first cohort was based on lunar space resources value chain, and the activity was project-based to increase the TRL, mainly on to support a ground demonstration. And the project is with the first phase that we call acceleration phase, where we will support the company in different activity, and then a project implementation. Mainly what was already said by Catapult and MEDES, by my colleagues. So we would like to support the commercialization of the company in the sector, and we would like to create an awareness. And as well, we are open to companies that are coming from different sectors or from the terrestrial sector in the specific. The 6 companies that are supported by the accelerator are Orbital Matter with Digital Manufacturing, Orbit Fab from UK, Refueling, Fibercot Manufacturing, Fiber Manufacturing from regolith, space power, lunar power beaming, Volta, similar at space power, space-based solar wireless power, and then Man Electric, issue manufacturing and power generation. Again, what is important here is to understand the broad activity that are related to space resources. And to explain to you what ESRIC is doing, and is in the scope of the BSGN, is actually to support the company in all their activity. So here you have some picture of what we did together with the company. So participation during different events, Space Resource Week or Space Tech or investor speech, and touring as well. So we are really going together with our company and promoting them in their let's say commercial activity. What ESRIC would you like to do with the BSGN and with the commercialization activity is to create an issue cluster, as we would like to be really the center of excellence in everything related to space resources. So startup, institutional activity together with the others, government, space agency, organization, research and academic that can support specific activity where the risk or let's say the TRL is still too low. And then we will do like support as well as we are doing with funding and financial activity. Related to the BSGN, we are going to have another call very soon that is in reviewing. The topic will be as well construction, similar of the one for the academic challenge, and will be consortium based for the, and the scope will be this time not for a ground demonstration, but to really prepare to move forward to the lunar activity. I'm leaving now the floor to my colleague. Would you like me to share, Kenneth, or?
Yeah, please.
Okay.
Thank you, Ernestina. So I'm going to talk a little bit more about the academic challenge and specifically the track for space resources. Space resources is all about using the resources that we find in space and use it in place. So we want to be able to find water and purify that so that we can use it for spacecraft refueling or life support in the lunar surface. These kind of resources are very valuable and they're found in certain regions of the polar regions. But if you zoom out a little bit and look at different areas of the moon, you'll find that regolith is very plentiful. It's covering the entirety of the moon. And you can find metals and oxygen and a lot of other silicates within this regolith. And that enables infrastructure construction as well as equipment manufacturing. Next slide, please. So for this academic challenge, we will be focusing on specifically the infrastructure construction. This is because ESA sees the moon as a spaceport to the universe. And we are now working towards bringing this to life, we should say. Next slide. So kind of looking at ideas, since my colleagues have talked a lot about the mechanics of the academic challenge and all of the support, both commercialization and pitch support that we'll be providing, I want to talk a little bit more about the ideas that are kind of what we're looking for in the academic challenge. For lunar construction, the standard kind of flow that you can see is that you would take some regolith, you excavate it and move that around. You bring that regolith into some sort of processing facility, which then turns that regolith into bricks. And then you can use those bricks to build structures, landing pads, and roads. So we are interested in any of these fields and any of these solutions if they can provide a very, very big increase in technology readiness. But the ideas that we're most interested in are, next slide, please. are the very innovative ideas. So this is like 3D printing construction where you can take regolith and mix it with some kind of binder and then be able to directly print the structure or the landing pads or the roads. Similarly, there are some ideas where you can take 3D printing and create some kind of foldable structures and, very similar to origami. And then that would enable you to build very tall structures that are very lightweight, yet you use mostly resources in place. And then finally, there's a whole class of inflatable structures, which are possible if you can use oxygen extracted from the soil. You'll be able to inflate those structures to be habitable, either structures or other sorts of infrastructure. So these are just a few ideas. We are absolutely not limiting everyone to these ideas, but we want to say that, innovation is really what we're looking for here. And that's the name of the game. So we're happy to support you on the way to your pitching and post-pitching, success. So, and then next slide. I think that's it. Yeah, happy to take questions once we reach the Q&A section. Thank you.
I want to thank once again all the partners from the accelerators that have helped us to pull together the webinar, and all of you for your interest. We look forward to receive your applications and to see you at the Space for Inspiration conference in Copenhagen. Thank you.